all the time about it. So as you can see, we have been discussing. What we're discussing today is we'll be talking about the ions and isotopes. We already done about the electrons, protons, and neutrons, and their atomic number and mass number, and how to determine a certain atom. So let's recall first what we have discussed before. So let's try this solve this one. How many protons, electrons, and neutrons are present in boron? So we are asked to determine, or we are asked to get the protons, electrons, and the neutrons in the boron. So we have the boron of 11. Okay, let's write here. Boron 11 of it. What is the boron? It's 11 is the mass number. Take note of that. It is a mass number. We're gonna write here A. It's the A. Okay. So and the 5 here is the atomic number. The writer Z. So to determine the protons and electrons and neutrons, it's very easy. The first thing to do is the one here, mass number here is atomic number. Like I said, mass number is equal to, I'm sorry, the atomic number is equal to protons and equals to electrons. So that means in a neutral atom, the electrons and the protons is 5. So we're gonna write P here, P positive. We'll write this one. This is the symbol for protons. So you have 5, and the electrons is also 5. So we're gonna write that one through this text. I'm going to write P. For zero, some negative. So it's equal to 5. So how about the neutrons? The neutrons is atomic number here, which is protons or electrons. So minus the mass number. So mass number A minus the Z or atomic number is equals to neutrons. So 11 minus 5, it's 6. So the neutrons is 6 in the present of in the bottom. Okay. So those are okay. So let's try to now let's move to discussion, which is all about the ions. So what are ions? Ions is very, I think it's familiar to you, but okay, let's get into solve this one. Okay. Ions are what are ions? Ions are atoms may gain charges. This happens when electrons are loose or gained by the atom. When this happens, the atom becomes an ion. That means we have what we call a neutral atom. Like for example, like I said earlier, the boron. It's a neutral atom with a mass number of 11 and the atomic number of 9. Sorry. It was 6. Okay. Sorry. It's 5, by the way, I forgot. Okay. So this is called the neutral atom. So for the okay, put some 5 here. So the ions becomes an ion so when it gain an electrons. That means it becomes gain or lose an electron. Since boron is a non-metal, they will be gaining electrons, so they're having negative here. So when they gain 1 electrons, they will be called ion. Or if they, like for example, in A, which is sodium, if they lose electrons because they're capable because they are metal, they will transfer electrons. So they will, what they're going to do, they will, um, they will lose electrons. So they'll be having positive here. So they will be called ions. Okay. Okay, it's more. So they're, so the positive sign, sorry, the negative, with the negative charge, they will be called an ion. So this one here, because it's sodium, it will be called sodium ion. Or we can call it cation because it is a positive charge. In here, it is called a negative charge. It is a negative charge ion. That means it is called an ion. That is just a term. Okay, so a charge of ion is equal to the number of electrons minus minus the number of, sorry, equal to number of protons minus the number of electrons. Okay, let's try to solve this one. Let's try to have, like, for example, getting to know what is a charge of ion. Like, for example, we have a sodium. Okay, let's go back to sodium. Sodium has a atomic number of 11 and the mass number of 23. So the question is the charge ion. Like, for example, this sodium here, it will become a an ion. It's have positive 2 here. That means they lose electrons, 2 electrons. Okay, so we have here, so the charge of ion is equal to the number of protons minus the number of electrons. So the neutral charge, the number of protons here is 11, right? Since it has positive here, it's a 2 positive here, it becomes 11 plus 2, it becomes 13, right? So there is the number of protons minus the number of electrons. So what is the number of electrons here? I sorry, I forgot. This one here is 11, the number of protons. Sorry. Okay. This one here, so this one here is the number of protons. This one is the number of protons. Then there's the number of protons, okay, minus with the number of electrons. So the number of electrons is, because it's added, it loses an, the positive two here, it loses an electron, so they will become what? It loses an electron, it becomes 9. So 11 minus 9, it is, what is a charge? 11 minus 9, it is 2. So we're having here 2 positive ions. So that is the charge ion. So if there is an Na, like for example, I put some ion here in A and 2 positive here. So it's very easy to know the charge because this is a charge ion. The number of protons electrons to the number of protons minus the number of electrons is equal to charge, right? Okay, let's give, like, for example, you didn't know, like for example, you didn't know the number of um, the charge ion, you didn't know the charge of ions. Like for example, you didn't know the charge of ions. What are you going to do? Like for example, the you have sodium here. Okay, let's go back to sodium. You have the sodium here. Have the sodium. And then the number of protons given is, like for example, 9, and the number of the electrons is given is, like for example, 10. Sorry. Okay, let's go back to this one. The number of protons, the number of protons is 12, and the number of electrons is 10. Just like an example lang. Okay. So it's minus here. So there are two the nine number of electrons you have, then the number of protons minus 12 minus 10 is 2. That means a positive, you loses an electrons. So you have this one, two positive. It becomes two positive here. This is just an example because the neutral atom is 11, right? Or like if you can just try this one, like the neutral you can use for the protons that it doesn't wala siya nailabtan. So it's for 11 minus 10. So you have here sodium positive or sodium ion. So it becomes like that. Okay, let's move to the other. Okay, let's try to have this one. Like for example, look at this one. Let's try to have it's a lithium atom. That means when you say lithium atom, it is a neutral atom. So that means the protons and electrons are still the same. So you have number of protons is 3. See, the number of protons is the atomic number. Take note of that. Electrons is the atomic number also in the periodic table of elements. So to get the protons, I mean to get the net charge is just going um to subtract protons subtracted by the electrons, so we'll be having zero net charge. So look at the lithium ion. It's going to be called lithium ion. That means there is a loss of electrons. Lithium is a metal, right? So there's a loss of electrons. So we have here a protons of positive 3, still the same, because it loses electrons of negative. The number of electrons here is negative 2. So or 2, which has a negatively charged, so we are going to subtract 3 minus 2. We have this one, um, positive 1, or it is a lithium ion, or we can call it, the symbol will be like this. We can call it, it is called, it is called cation, right? This is called cation because it is losing electrons. Take note when there is a positive one here, or we can remove this one. We can put it some, like for example, lithium. We can put some positive at the top, which identify that there is a loss of electrons, which is only one electrons. Okay, no need for the one. Okay. Okay, let's move to the next one. Okay. Okay, let's try this one. Determine the number of electrons, protons, and neutrons and fluorine. So we have 19 for the mass number and 9 for the atomic number, which has the negative 1 for its ion. So this one is called an ion because it has a negative 1. Take note of that. Okay, let's try this one. So you have here fluorine, you have here fluorine, negative 1. So this is the charge. So we're going to find the electrons, protons, and neutrons. So for protons, we have, how many protons we have? Still, we have Still for protons, we have a nine protons. Since it loses electrons, oh sorry, it's gaining electrons. So since it's gained electrons, so um we have here the this is gained electrons of one. So how many electrons we have left? Electrons we have, it's you gained electrons. You'll be having eight, or you gained electrons, so you're having a 10 electrons. 10 electrons. Since the charge is equals to protons minus the charge, protons minus the electron. So the charge is -1, which is you have gain and electrons. That is how to get those. For electrons is 10, and how about the neutrons? I'll be going to get the neutrons. It's very simple. 19 here for mass number minus 9. So 19 minus 9, we have 10 for neutrons. That's it. That's how simple. Okay, let's move for it's how simple it is. Okay, let's move to the next one. So let's talk about what is isotopes. Isotopes are what are isotopes? Isotopes are atoms having same atomic number but with different mass number. That means they have what they call atomic numbers, the same atomic number. Like for example, fluorine. What is the atomic number of fluorine? It's 9. So the mass number is different from its usual number. So it changes. Like for example, so the isotopes of hydrogen we have here, which is called prothium. Atomic number is 1. The mass number is still 1. It's called prothium. So the protons is 1. The neutrons is 0. As you can see, how to get the neutrons? It's very easy. Mass number minus atomic number is equals neutrons. So 1 minus 1 is 0. So that's why it's 0 here. And the electrons is 1 because electrons is same the atomic number. Okay. Deuterium is wherein there is 2 or there's 2 mass number. So the mass number here is 2. So got the neutrons again is we're going to subtract mass number minus 1. So the neutrons become 1. So they are called isotopes because of their mass number. We have changed their mass number. The neutral mass number is called the mass number is 1, right? It's a neutral one. So it's going to prove it. Okay, so when there is a 2 mass number, the mass number, so it's called deuterium, and there are 3 mass number, it's become tritium. So that's how the rule works. Okay, like for example, so okay, like for example, the isotopes of carbon. Like for example, the isotopes of carbon. We have here carbon 12, carbon 13, carbon 14. That means the mass numbers become 12, 13, and 14. The coefficient. So the carbon has atomic number of 6. Okay, the carbon is has the mass number of 12. So this is the neutral one. So it becomes here next called carbon 13 from carbon 14. So during the focus, when there's a change of its mass number, they are called isotopes. So these are isotopes. They change their mass number. Look at the neutrons, it changes also. Mass number minus the atomic number is 6, which is in neutrons. They are called pure neutrons. So we have here 6, look at here. 13 mass number minus the 6 have 7 neutrons. 14 minus 6, it has 8 neutrons. So that is how you're going to get the neutrons, the isotopes. Okay, let's move to the other ones. Okay, I'll be giving you an assignment. This one is an isotope. We're going to fill in the numbers missing here. Okay, like here, boron 11, zinc 14, this 11 here, take note, this 11 here is the atomic number. Oh, sorry. The 11 here is the mass number. It's very easy to identify. What is the 11 here mass number? 24 is a mass number. 27 is the mass number. 32 is the mass number. So fill in. What is this one? This is Z, A, the protons, electrons. So I think you don't need a periodic table of elements because you'll be able to know the we'll be able to know the atomic number by this one here because there's a given one, like for example, here positive. Okay, let's try to answer number one without having okay. I'll be giving bonus for this one. Boron is a bonus. So you're going to answer 1, 2, 3, 4, huh? Okay. Like for example, you need to this one. Right here. We have this one, elect we have the protons of 5. The net charge is 0. So we have here negative. So it's an electron. So we have the same. This is 5. Okay. So we have the neutrons. Okay, 11 is the mass number. 11 minus 6, it is 5. So for atomic number is 5. Still the same. The protons is 5. That means the atomic number is 5. Or if we are very need like a concrete answer, and also neutrons minus the atomic number becomes your minus the mass number becomes your atomic number. So you have 5 atomic. Okay, the rest, answer the rest. Green, amazing, and turned in our Google Test. I think that's will be all for today. Bye on the